Hi, this is Samir and welcome back to another video tutorial for Effex 2.7. Today I'll be showing you how to create foam and spray. For this video tutorial, I'll be using one of the preset scenes that we find in the toolbar, the Open Water Wake preset. Let's get rid of this command tag. And in this scene we have 192,000 particles emitted. So for my render voxel size I set 0.2. Currently we have 0.3 because I would like to have it a little more particles, so a little higher resolution. And I've made a pre-render of the results, which will look like this with about 620,000 particles. This is a nice mid-resolution and it just fits the video tutorial scale. I also get rid of this meshing setup. We don't need it right now. I just first of all want to create the simulation, and I make some changes to the default setup. In the Fluid Dynamics tab, in the Solver sub-tab, I choose a different solver. Instead of the Gauss idle, I use the conjugate gradient because it preserves the volume much better, which I want here, definitely. Alright, I also open up the top, so when there are splashes, as we could see here in our pre-render video, hitting the top, they shouldn't slide along the top as if there was a wall. So I just open it up and the particles will be killed at these positions once they're outside, as we can clearly see here. Okay, that should be it for the initial setup. I don't want to put too much detail in here. We want to talk about foam and spray. So let's go back to our Effex scene, into our cache wizard, because I want to cache that simulation now. So I click on collect all cacheable nodes, which will collect all cacheable nodes like the fluid dynamics and the particle group used. I also only want to cache during rendering. I want to save my cache, of course. And here in the particle file type, I make sure I use the latest version of the Effex file format for particles. The grid file type, so for the velocity field I can keep like that. I use a user-defined path. So I click now on select destination folder and choose my user path for taking all the cache files. And I choose a file name, of course, and I can just have a single one because all the particles and all the other stuff will be having a different suffix. Also compress if possible, and well, that's it. I set up my cache nodes, which will be created now. The pop cacher is taking care of the particles and the gob cacher of the velocity field. And now I could actually start my rendering to cache that simulation. And for that I use the hardware rendering mode because I want to see my particles, which will give me a much better impression of how the velocities, etc. and all the splashes are working together if I hadn't made a pre-render beforehand. The rendering is finished and it took about 3 minutes longer due to the caching. But let's take a look at how it looks. Should be approximately the same as before, as it is. Okay. So let's now try to load this cache. For this we go into the Effex scene again, into our cache wizard, and we cannot keep everything that we had before. That's a great thing about it. We just changed the cache mode to load, and well, we also create another Effex scene here. All good. Let's just set up the cache nodes, which will create a second Effex scene. So we can now turn off our initial simulation scene. So this one is safe. We can always change it later on without changing our cache loading if we're adding features or forces or whatever. In our cache loading scene we have a pop cacher, which of course loads the particles into the particle group we have here, which is a low-level element. Beforehand it was encoded in the liquid flip node group, but here we have the actual particle group. The same is true for the fluid dynamics node here, which is also a low-level node. But what we want to change is our global voxel size in the editor because we want everything to be in sync with the render voxel size that we had in our simulation scene. Well, we are now ready to actually load our cache. In our pop cache, we turn off only during rendering. So we get our cache loaded already in the editor view. I take out the ship obstacle. I want it to be visible. And let's jump to an interesting frame right away, frame 30 here. And we can see some splashes, but the difference is we don't see these bright and dark areas anymore. That's because in our particle group, we still have the old velocity property that is encoded in the liquid flip node group inside of our new scene. So it can't see that particle property. So let's create just a new velocity property, which is down here, create it, and now we can see our velocity intensity. Also change the range maximum threshold. Let's jump to another frame, maybe frame 70. Here we go. That looks like an interesting frame to set up our foam and spray. But first thing we need, of course, before we can start with our foam and spray, is we need a mesh to create for our liquid particles. So let's create a node group, liquid particles mesher. You already know this one from our previous tutorial. If not, check it out. And I changed the voxel scale, so lower the resolution. We can see these 4 nodes now have been added to our pipeline viewer. Also that you have already seen in the previous tutorial, so I won't go into any detail. If I turn it off, they disappear out of the pipeline, otherwise they come back. Okay, so we have to choose a particle group to mesh. We choose our flip particles. Once we have done that, we can see a surface mesh has been generated, but it is kind of inside of the liquid particles. If we turn it off, we can see it, but it's not really wrapping around the particles yet. So let's change that. We go into the particle radius setting and change it to 0.55. And just an advice, never go below 0.5. It just doesn't make any sense. And what we also need to change is the surface volume mesh surface offset, which is 0.45 currently. If I set it to 0, we can see that the mesh is really wrapping around the particles. Much better, but it's kind of blocky, so actually we could use some smoothing passes to smooth this result. But you would be ill-advised to go this path because it also gets rid of any sharp features that the mesh is exhibiting. So we go back to one smoothing pass. What we instead do is we change the voxel scale to a higher value, which will give us a higher resolution, so more cells to actually sample the particles and get a better mesh out of it, more detailed mesh. Of course you can go even higher, but it will take longer to calculate, so we keep it at 1.5, and our follow-up length we set to 3, for example, which is a nice trade-off between smoothness and remaining features or sharp features. I can also increase the mesh surface offset slightly, and the higher I go with the voxel scale, the more offset I could use because the voxel size will get smaller. Alright, so this looks pretty cool actually. I don't want to put too much effort in this one. I guess you get the point. You tweak your mesh until you're satisfied. There are other features you could use, but let's keep this one for now. I'm quite sure this is enough to show you how to create foam and spray. But let's not forget about a GOP cacher, which is loading the velocity field, which we need. So let's turn off only during rendering also for this cacher. Okay, so we have everything in place now. We have our mesh, we have our particles load and our velocity. And now we need our foam and spray operator. Here in our toolbar for particles, create it, throw it into our Effex scene for cache loading, and we can see it is put down here in our pipeline viewer. Now we still need to define our inputs. First of all, of course, our flip particles. which we have here. Choose that one. We could also set a particle group for foam and spray separately, but we just keep our default particle group. We also link our dynamics for the velocity field, which is used for the foam particles. And we choose our masher for, well, generating in geometry modes the foam and spray particles, and have topology for curvature calculation, etc. So we go one frame further to actually evaluate the foam and spray object. We just have to do this once, like this, and we can see 342 diffuse particles, so diffuse particles are foam and spray, have been generated. Let's turn off our mesh and turn on our particles. Oh, we still see the liquid particles, so we go into the display tab, liquid particles, and set draw each X particle to 0, so we only get our foam and spray particles being visible in the area view. Go back into the foam, spray, and bubbles object now. Let's just turn on our mesh again. And now the cool thing about this foam and spray operator is that it is a live operator. So whatever changes we make now in this frame, without stepping further, we can see the actual changes live in this frame. So let's reduce our sampling density, and we can already see the change now here at the wave crests mostly, and we have 8,721 particles now. And we can now, well, turn off spray generation, and we can see that if we turn it on, they have kind of a priority over foam particles, so they're rather generated than foam particles. Well, let's go into the spray settings and just set some things, for example, our threshold for velocity, and which give us this result, which I very much like actually right away. Also can set a vorticity, so a turbulence value threshold when or where spray particles should be generated, like this. Maybe go 4.5, and now I can change some random values, so we can just, well, randomize the output and the generation of spray particles in this case. Well, the lifetime I could keep like that because I don't want them to die in mid-air actually. And our normal velocity is a multiplier, but we can set it pretty high because of our scale, and you can see it like it would be, well, in centimeters or meters or whatever Cinema 4D unit you have. So I set like 8. If I set 80, you can see the difference here, how further along they're emitted. So I keep it at 8 and just give it a nice random value, pretty high actually. Well, I can set a max angle of spreading, so like a spawning angle, and also here I put a high degree of randomness to that one. And the last thing I want to change is the velocity multiplier. So here comes the velocity field into play. I actually want it to be quite low. You will see that this has quite a strong effect anyway. Now let's just keep it like a, well, a time step if you want so. And the randomness is fine to me. Maybe set some drag so they're not pushed too far away from the wave crests. I could put them higher so they're kind of going backward, and could put it lower in negative space so they would be pushed further away. But we keep it at 0.5, that seems reasonably well. Okay, I'm quite satisfied. So let's go to foam, and here we have offset to surface, which is not directly applied in this case, but this one is easy. I can set it to the same amount as I have in the liquid particles measure for my mesh surface offset. So they will kind of be in sync if these two values are synchronized. Okay, so I keep that one. And next thing is also here tweaking settings, and you can see if I choose a higher curvature threshold, it gets a little less. Do I want that? No, not sure yet, so I changed some other settings like velocity threshold and vorticity threshold after all. And this works of course the same as for spray. I set a low lifetime actually because I kind of noticed that foam is not living that long actually. It's just a lot of foam being generated usually when waves are, you know, breaking or something like that. But I use a lower curvature threshold, so I get the foam at more places, even at kind of lower wave amplitudes. And well, keep on tweaking here my velocity and vorticity threshold until I'm actually satisfied with what I'm seeing here. Just put it quite low. I want more and more and more. And rather choose vorticity, which is a little more sparse in its result. Well, I like that one. Maybe some random values just for the sake of it, why not? It's always good to be flexible and variable. And I think we got it now. So my foam and spray setup is pretty much complete. But this doesn't mean we're finished, because the generated foam and spray particles wouldn't actually move. They're still only generated and emitted, but we still need to make them move. So let's go into the flip particles group, and we have the advection quick tap button here, and we choose diffuse from the pop-up, and this will create a pop advection node for our diffuse particles. Let's go into the settings of the pop advection, and we have diffuse already set, and here in the mode we change from ballistic to dynamics and ballistic if outside. This mode is kind of specialized to handle foam and spray particles, so you just have to know it. But that's about it. And for the spray particles, we also would like to have a gravity, of course. So as ballistic particles always use the goal gravity, we set it here minus 9.81. And now we have it actually finished and everything is in place. The last thing we now do is we cache our diffuse particles, and we still have everything in here. Great. And we delete the dynamics and only keep the flip particles. But for now, not the liquid, but the diffuse particles. So we click on this little icon here, which simply stands for the fourth subgroup, which is the diffuse particles. And we also change the cache mode to safe, and we set a different name because we don't want our caches to be overwritten. So we say just foam and spray for the file name. And now we set up the cache nodes, which give us a second pop cacher, especially for the diffuse particles. Also under doing rendering, which I want. And let's just rename it so we know which one does what. Simulation and caching is in place. Now we need some rendering options. And the most straightforward way is, and of course also the most simple way, you can find in the parameters tab of the particle group, render size foam particles, render size spray particles. Just set it to 1 centimeters. These are render spheres. We can see them here, not identify them yet, but so let's create a new material. I'll just use luminance here, maybe a little lower. Put it on our particle group and, well, render. Yeah, this is much better. We can see them now, but we can also see they're way too big. So let's change them a quarter of this, and maybe here, I don't know, 0.4. Seems reasonable. Render. Yeah, that's much better actually. Maybe we use a little higher luminance. Oh, and before we go on to the actual rendering, I have made a pre-render of the mashing we had. So let's just take a look at how this looks without foam and spray. Like this. This is our render mesh. That's quite okay, definitely. not highest quality, so you should definitely tweak to get the best out of it. But enough for this video tutorial. And this time, instead of using the hardware render mode, I want to switch, of course, to, well, a real render mode. No, not software, but standard. Keep the rest. I have the caching, the simulation, and the render elements. Okay, let's render this. Okay, I just, well, get the picture viewer in front here, and I'll be back in a jiffy to show you the actual result of our video tutorial. Here we go. Rendering has finished in 2.5 hours. This is actually quite long, and let's take a look. As you can see, a lot of particles have been generated actually, so it was okay with the sizes we used. It looks, well, quite cool actually. We can see some particles being or falling down at the very edges here. This is because we have our simulation domain a little bigger than the actual particles, so we could, before we did this, adapt this to wrap around the mesh more tightly. And of course we can also simply open up all the container walls so all the particles outside of the container would die. I hope I could show you how fast and how straightforward it is to create foam and spray for liquid simulations in Effex 2.7. Hope it was helpful. In the next tutorial I'll be showing you how you can render the foam and spray particles with Krakatoa, for example, or with Arnold for C4D. Take care and enjoy Effex 2.7.